First of all, I would like to welcome you all to the session on disaggregation. It is simply sound engineering. My name is Julius Francis. I'm Director of Product Marketing at Juniper. And joining me is AE Natarajan, SVP of Engineering. We are here to discuss the cloud principles and key innovations that are needed to get the cloud outcomes. Mainly discussing disaggregation without trade-offs and the sound engineering that solves the cloud optimization problem. So let me start by reminding us all that how our cloud has transformed over the past 2 decades. Applications evolved from self-contained monolithic architectures to distributed microservice architectures. Underlying networking also evolved to support this application evolution. Cloud adoption also picked up at a breakneck pace. So over the last 2 decades, we started off with private cloud with 1 to 10 gig capacity connections. Then we moved into building public clouds with 10 to 40 gig capacity connections. Now with pervasive adoption of the cloud, we are moving into 100, 400 gig and beyond capacity era. So applications architectures and the adoption of these applications are shifting into an overdrive. Application-driven infrastructure must evolve to meet these demands. So what does this mean? As we scale the cloud, the problem space is shifting. The cloud infrastructures are evolving to meet that shift. So technological innovation must evolve too. Hence, how we engineer a solution is key as we respond to our customer needs. With that as a background, let me begin our discussion with AE. So AE, thank you for joining. So as these cloud infrastructure trends shift at rapid pace, our cloud customers are embracing disaggregation. So you have been innovating in this infrastructure space for a long time. So what is disaggregation means to you? And what is Juniper's journey over these decades?
Thank you, Julius, and hope you're having a wonderful day. When you talked about the transformation that we've been going through for the past 2 decades, it actually brought me to thinking about what we were doing 2 decades ago, where Verizon was telling us, hey, can you hear me now? And then AT&T was saying, reach out and touch. Today, we have to not just reach out, connect, see each other, hear each other, and also share content so that we can collaborate with each other. This whole transformation of how we could actually accomplish this happened through some of the fundamental sound principles of disaggregation. It all started with cloud initially disaggregating compute and storage and giving flexibility, reliability, and openness as the key ingredient pillars that drove costs through the scale and economics that the cloud could actually give us. Without which, it is unthinkable how we could actually shelter at home today and do all of the things that we're doing today. It is completely unthinkable if we didn't have these tools in place for us today. And many of these things came about with innovations and disaggregation that happened a long, long time ago that kept all of these principles and added on security, reliability, and consistency with ability to perform. Today, the dynamics of the traffic patterns, just because we are working from home, has completely changed. It's gone from an office, and when you talk to service providers or to the cloud providers, it is actually coming from homes. The peaks that they are seeing are similar to online shopping peaks that you would see during the holiday seasons or even more. And the ability for the network to actually transpond, to adapt, to accommodate, and to make things happen is what this sound engineering has actually given us. And this journey, like you said, is about 2 decades started when we first started with it. Let me first go with some of the things that we did with Junos over the last 2 decades and give you the transformations that we have done. So Julius, let's look at the Junos picture of how we have done things. The fundamental things that we've been talking about in Junos is how do you accomplish this through the last decade, as cloud and cloud-based applications started transforming this world and building out more and more demand in terms of how applications are run and the user expectations of how these things could be done in this fashion. We needed to have automation. So in Junos, we injected a lot of telemetry and automation and API sets for people to be able to adapt, script, and build out on top of our Junos operating system. We also build programmability, which is the API sets that I've been talking about, all the way from the forwarding or the data plane layer, all the way up at the control plane and the admin and manageability plane to give users, applications, cloud providers ability to fine tune use cases and to adapt to the growing and changing needs of what it is. In the meanwhile, Linux as an operating system has become the de facto operating system for all applications and hosting applications and solutions. So we built a network operating system, which is the Junos, on top of Linux to allow for third-party applications and several others to be able to add on top of our baseline to provide the value and to realize the value in an immediate fashion and to scale out. On top of all this, we have taken this whole thing and we have actually disaggregated it to smaller modules and microservices across the network operating system that gives great flexibility and all the sound cloud principles that we talked about, scalability, reliability, with security, without compromising on any of these things. And these were all built with some of the fundamental disaggregation principles. Going back when Junos first started, Junos was not a monolithic operating system. It actually had the control plane separated from the kernel. This disaggregation gave us ability to allow for applications those days to traffic engineer, to traffic shape, to control and program the network so that they can actually provide SLAs to the application, both for the clouds as well as for the client server application that are transforming to the cloud, and now microservices and mobile workloads that are coming in and completely disrupting the traffic patterns. That's, to me, Julius, is what is the fundamentals of how we have taken Junos and evolved it through the years to make it available for the cloud vendors. We didn't stop just here. We actually should go and have a double click on how we have turned this around and this disaggregation both into our Asic and into some of the fundamental NOS principles that we have built.
Awesome, thank you. Okay, let's definitely, I think this is an interesting perspective that you are sharing with us. So let's go and look into those ASIC choices and network operating system architectures that we as a Juniper is delivering to our cloud customers. Please go ahead.
Yeah, so Julius, like I mentioned before, the cloud customers want to have optionality or different options. And they also want to have scale and economics for all the different use cases and applications that are coming in. The application demands are a lot more these days than it used to be before. And the traffic patterns, like we talked about, people working from home or doing different things have changed dramatically. So the cloud providers want ASICs that can cater to all the different use cases that they are using it for. So in Juniper, we said we would not only build our custom ASICs, we would also be able to build routers and switches with commodity ASICs that are available in the marketplace to provide these networking solutions to our cloud customers. We actually took it, and one of the fundamental principles, not just for economics and performance, is also automation and telemetry, which is important to scale and build these networks. What we have done is we have provided inside the ASIC fundamental capability to have native telemetry come out of our own custom ASICs. This is used by a lot of cloud providers to actually understand what dynamics and what things are and what traffic patterns are going on in their network, so they can actually fine tune and build their networks and scale their networks and adapt their networks to the growing and changing needs that we have with the ASICs that we have built. We have also provided them APIs or JET APIs that scale up and down the stack all the way into the data plane, where somebody can go in and program the data plane to direct a packet or an application flow through the network that provides the right level of SLA. Great example is our video conferencing. We have video, we have audio, and we have content that is coming in as three different streams. And each one of them actually have its own requirements and is very, very sensitive to the network jitter, delay, and throughput. What we've done is the ability for us to stitch this together and give our customers, whether it's service providers or cloud customers or cloud providers, ability to use this ASIC and actually make this happen for them. And that is one of the fundamentals of what we did with the ASIC. Next, we actually took our Junos NOS or our Junos and we built it into what we call as Junos Evolve. So Julius, as you see in this slide, the network operating system is something that is fundamental to building some of this flexibility and scalability and the ability to actually transform in this changing and growing days. Let us look at Evo as a system that we built. One of the fundamental disaggregation principles inside Evo is the ability to take state out of the kernel and put it into a separate state database. This is the next evolution of what we did with Junos, where originally Junos was disaggregated. We started with fundamental, wonderful engineering principles of disaggregation, where control plane came away from the kernel. Now we have taken the state of the kernel and moved it out of the kernel. We've also built native telemetry and streaming telemetry inside that. We've built a rich set of APIs, where today, Julius, I would go to my engineers, and if they wanted a feature or a solution, the first thing I ask them is, do you need to code it, or can you script it on top of your APIs? If you can script it on top of your APIs, you can actually build it faster, and you can actually deliver it faster to the cloud customers whose needs are growing and changing in a very, very fast pace. These are some of the fundamental things that we have done with Junos Evolve, and this is one of our leading operating systems that's coming across 20 different platforms in our routers and switches over the next several years. Actually, the end of this year, it'll be 20 plus platforms that support this operating system that has been adopted and gives the great flexibility that you talked about in the first slide with the advent of mobile computing, with 5G coming up, with IoT coming up, and several other demands that are happening in the network and the transformations that are happening. We, as a company, are never afraid to disrupt ourselves. We can take this Evo, and not just Evo, but also the fundamental software that we have within Juniper and disaggregate them. Julius, we should actually go into and see how we actually build disaggregation as a double click into some of these other entities where we are ready to disrupt ourselves and take us to the next level.
This is awesome. Thanks for sharing these foundational investments that Juniper is making and how sound engineering comes to play. And you made a very good point here on how Juniper is not afraid to disrupt ourselves to serve the customer needs. That is a very critical, especially as the cloud demand shifts. And let's go and look at some of the issues that you talked about, especially if you could cover some of the more examples on how the disruptions that you are doing to help our customers, that would be great.
Yeah, definitely, Julius. Let's take the first example of what we call as containerized cloud routing, or CRPD as we call it locally. CRPD is the control plane or the routing protocol stack that Juniper built from day one. This is something that is of immense intellectual value for us because we continue to innovate, we continue to build it. And this is the one that runs the internet today at scale and performance. If you take packets that are going through the internet, invariably, every packet would pass through a Juniper router that uses this piece of code. And it's controlled by how this piece of code changes the path and the way by which routing happens. This is a robust, scalable entity that is a huge intellectual property for us. We have taken it and we said, we want to containerize it and give it the ability for people to take it and put it in not just network devices, but in servers and other places where they would need this intelligence to build not just cloud applications, but to cater to the SLAs that the cloud applications are asking for these days. This is simply a low footprint. It's actually less than 400 meg if you take just the code and a basic configuration into play. If you add a lot of routes, it scales with the routes that you have. Guess what? It's very easy to instantiate it. It takes the orders of 1 to 3 seconds to actually bring up this container. Not only can you do this, we can actually leverage how people have actually doing using Kubernetes and or Docker swarms to be able to manage the instantiations of CRPD across a plethora of devices where you can put the CRPD into. We've been talking to some large service providers in the Asia region. They're looking to have a holistic 5G deployment across the entire span. And one of the fundamental economic things that was driving them was to take a white box and have robust routing that gave them this capability to build out the backhauling and the mobile connectivity that they needed for 5G. They've been working with us to try and build out this using something that we built called the Containerized RPD. This is something which is a true example of how we are not afraid to disrupt ourselves and bring this value back to our customers and drive this even more. Not just in containerized routing, Julius, we can talk a little bit more about open systems and the sonic environment under which we also continue to innovate. We participate in sonic because this actually gives the cloud providers an open framework under which they can take white boxes and other boxes and build out cost-effective solutions where they need it. Many of these sonic devices were using free routing that was available in the network for their minimalistic needs when they first started. About a year and a half ago, we went to OCP and demonstrated CRPD. The growing and changing needs of this sonic ecosystem caused them to call us and say, hey, you know what? I can use CRPD because free routing does not have things that I would need, like management protocols, like policy engines, like all the power that you have with the Juno's routing stack. Can we use it? We gave them the CRPD and they were able to actually plonk it into this environment and be able to build use cases and solutions that can go a long way. Not just with CRPD and Sonic, we've actually done a lot more to Sonic. We've taken Sonic and had multi-PFE systems, not just single fixed form factor systems, because we need the scale and performance. So we are innovating and contributing back to the open community of Sonic, where we deliver on multi-PFE systems a very, very scalable and usable solution that can actually help build huge, large, high-scale networks using this. What does Sonic offer to the cloud customer? It gives them an optionality where they can actually get the disaggregated hardware from someplace, use the Sonic environment, and take the best of breed software and build it for their use cases and fine-tune it for their growing and changing needs of these use cases. Like I said, Julius, in Juniper, we are very, very strong in trying to look at all these trends and disruptions and are never afraid to actually change our course and disrupt ourselves. We were built on the fundamental principles of how disaggregation can help us from day one, because that is how we built Junos. Using that and evolving that and leveraging these sound engineering principles, we've actually brought a lot of innovation and a lot of value to our cloud customers and several others who are building out large-scale networks to meet the growing and changing needs of this day and age. That's my pitch on what we have done so far.
This is great, awesome. I think we, in a very short time, you covered a broad set of disaggregation solution that you are doing, and you are bringing the sound engineering to solve many of the customer needs. Definitely, I think delivering the operational simplicity at scale is an essential success factor for our cloud customers, as you know it. So as we bring this to close, tell me about the technology innovations that Juniper is making on the operational front. to actually transform the cloud infrastructure landscape.
Yeah. So Julius, that's a very, very good point. On the operational side, like I mentioned, we are teeing up each one of our innovations and having a one Junos experience across how people build their solutions. These carry elements of openness, carry elements of how automation can be done, how the APIs use open config, streaming telemetry, capabilities that we actually leverage for people to be able to build their own solutions on top of it. Last but not the least, with Junos and with Junos Evolved, like I talked to you, it is an open platform where people can bring in their own innovations, their own applications, and host it inside of our environment. While we are doing this, we're taking things which are fundamentally important value that we have created with our routing protocol stack like CRPD, taking it into a container and exposing it for others to be able to use it in all of their different use cases and leverage the benefits of what it gives in terms of scale, performance, policy engines, and value that it actually brings to the table. And not last but not the least, but the whole plethora of us adapting to different ASICs, both custom ASICs and commodity ASICs, and building some of those fundamental things like streaming telemetry within the ASIC and APIs for people to program the data plane gives a lot of flexibility in how we deliver this one Junos experience across a plethora of innovations that we talked about.
Thank you, AE. I think it is a great discussion. I think we touched upon a broad set of ideas and the innovations that you are doing in the disaggregation space. Cloud industry is looking for more innovation in this disaggregation space. And you shared some ideas and the engineering sound principles you're applying, and that Juniper is well positioned to deliver these innovations, especially as the cloud infrastructure becomes the anchor point of differentiation for many of our cloud customers. Again, thank you all for joining this session. We will be having some deep dive sessions on some other areas of disaggregation, especially on Junos Evolved, Container RPD, and Sonic. So please make sure to spend some time and listen on these sessions. Thank you all.